Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
So in the last video we learned about series circuits. Today we're going to learn about something called a parallel circuit. Parallel circuit? Parallel circuit? Is there one R or two R's in parallel? I think there's one R. There you go, a parallel circuit. So when we talk about a parallel circuit, it's kind of interesting to think about like driving to school. Now, if there was only one way to school, right? That'd be like going in series. And if there's a problem, if there's a resistor, an accident or something, you're in trouble, right? But every road has resistance, if you will, traffic, right? And parallel circuits is like different roads. So let's say the school is here and your house is here. What if there were lots and lots of ways? Remember, and let's say that the goal of everybody like in Houston is to go from their house, from your house, to the school. And if we wanted to increase the opportunities for there not to be log jam, then what we would do is, of course, we have more than one route. And that's the idea of a parallel circuit, or analogy that's going to make the most sense as we go forward. So what is a parallel circuit? Their definition. So resistors connected across the same potential difference. Remember, that's your voltage, right? All right. And the equation is going to be similar but different. So we can say 1 over R total, notice it says reverse or inverse relationship, is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc., depending on how many you have. So that's a parallel circuit. Well, of course, we're going to now do an example. So here we have a parallel circuit, and we've got three different resistors, R1 with 250 ohms, R2 at 150, and R3 at 350. And if you think about it, as the electron goes out here, he has three different options and choices. He can go through R1, R2, or R3. Some will go through one and some another. So it's going to like speed up the traffic, if you will, right? We also know something about the current. No, we're trying to find the current. So if we're going to try and find the current, we're going to use the equation V equals IR. But R is going to be like the total R. We have to solve for the total R because we have this weirdness going on, right? So let's figure out how we would do this problem. So I would say, I would say 1 over R total is 1 over 250 plus 1 over 150 plus 1 over 350. Now, I'm going to get my calculator. On my calculator, I'm literally going to, you can just write it exactly like that. So 1 divided by 250 plus 1 divided by 150 plus 1 divided by 350. Now you can do all kinds of weird fractional stuff, but you know what I get? I get 0.0135. But that's equal to 1 over R total. So if I want to get just the R total, you have to take this to the inverse power. So if you take this, if you will, 0.0135 to the power of -1, that's inverting it. So I'm going to, on my calculator, I'm going to go to caret, or to the power of -1, and I get R total to be 74 ohms. So let's think about this. This number makes sense. And you say, wait a second, if 250, 150, 350, remember the electrons are moving through the wire and they have three choices. So the options, of course, is the overall resistance is going to go down because there's more choices, right? Now the question is, what's the total current through the system? Well, the total current, V equals IR. I now know R and I know V, so this is 24 is equal to I times R, which is now 75. Divide 24 by 75, and you get 0.032. So I equals 0.032 amps. Now in the second part of that question, it says, what is the current in each segment, right? So you've got segment 1, 2, and 3. So now we're going to solve for I1, I2, and I3. So let's kind of rewrite this equation so it's easier to think of it. I can divide both sides by R, so I is equal to V over R. And I'm going to do I1, I2, and I3. which will be V, this is R1, right, over R2, V over R3. This is 24, 24, 24. I'm doing this kind of all systematically. R1 was 250 ohms. R2 was 150 ohms. And R3 was 350 ohms. And we can do this. We can find our currents. Our currents are 0.096 amps for this one. 0.160 amps for this one. And 0.0686 amps for this one. Again, I bet you aren't terribly surprised. That's interesting. You know, I was doing a mistake. I realized, folks, this is 0.32 amps. I was saying something was wrong here. So this is 0.32 amps. That does create some issues because I was about to say these must all add up to this number. 0.096 plus this add up to this number. And they should. But that's not a 0.0. I just read my notes wrong. All right, so that's how you do a parallel circuit. Well, Houston, that's how you do parallel circuit problems. I don't think we have a problem. We'll see you in class.